We're going to look at solving quadratic inequalities. One way to solve a quadratic inequality is to go ahead and graph it. And we're going to be looking at that in a little bit. But to begin with, we're going to graph, instead of a quadratic function, it's going to have a greater than or a less than sign here instead of an equal sign. In other words, we're going to end up having to graph this like we would normally, but then we're going to have to do some shading. Either shade inside the parabola or outside of the parabola. Well, we're still going to use that negative b over 2a. When we do our negative b over 2a for this problem, we end up getting a 3 over a 2. So then you want to choose three numbers on each side of 1.5. So you choose three numbers below 1.5 and three numbers above 1.5. You can plug those into here, and then you can plot your points. Now we can't use the pattern of over 1 up 1, over 1 up 3, over 1 up 5 because our vertex is not at a nice grid point. It's at a fractional spot in between. So all we're going to do is just plot those points. Then we'll have to decide, do we shade inside or outside? Also, since this is just a greater than, not a greater than or equal to, when we graph, we're not going to graph with a solid curve because there's no equal to here. It's just a greater than. So we're going to have to go ahead and shade with a curve or a dotted line. Now, in this case, I have shaded on the inside, but let's see why. You want to go ahead and choose a point that's not on your graph. So I'm going to choose this point here, 0, 0. I always like to use the origin because zeros are easy to work with. The only time you can't use that is if 0, 0 is on the part of this dotted or solid curve going on the outside. So since your y is 0 and x is 0, you plug in 0 here. You want to know, is that greater than what you get when you plug in your x coordinate over here of 0? Well, in this case, that's what we're doing down here, and you end up getting 0 greater than 2. That's not the case. That's a false statement. 0 is not greater than 2. So we tried this point, and it didn't work. It made it not work. It was false. So that means you got to shade on the other part of your parabola. So instead of this over here, it doesn't work on the outside, so therefore you got to shade on the inside. So that's what we're going to do here. You're going to do your negative b over 2a, negative 4, opposite of 4, over 2 times the negative 1. So in other words, you get 2. Then you want to choose three numbers on each side of 2, and then figure out your points. Now, you make your t-chart if you wanted. But since this is a nice, neat number, you could go ahead and find the x-coordinate of your vertex by plugging in 2, which you know is this point right here. 2, 6, and then you could use the pattern of 1, 3, 5, 7, since it's at a nice grid point. But remember, since you don't have a 1 in front, you got to multiply this pattern by that number in front. So you'd have to multiply everything by a negative 1. So you go over 1, down 1, over 1, down 3, over 1, down 5 from your vertex. Now in this case, it's a solid curve. It's opening down because, once again, it's negative, but it's a solid boundary line here because there's an equal to here. Whenever it's an equal to, it's solid. Whenever it's not an equal to here with your inequality, then it's a dotted. Then, once again, you could choose a point. I like to use this point here, 0, 0. Plug in 0 for your y. You want to know, does it make it a true statement when you plug it in here? Well, you get 0 greater than or equal to, and then over here you get 2. Is 0 greater than or equal to 2? No. So you chose a point on the inside of the curve, and it didn't work. So that means you got to then shade the outside. So now let's look at solving quadratic inequalities with the idea of graphing. Well, you'd want to have 0 on one side. And so now we're going to go ahead and replace your 0 with a y. And we're going to graph that resulting quadratic inequality, just like we were doing before. The negative b over 2a Make yourself a t-chart or find your vertex of 2, -1. You get the -1 by plugging your 2 into here. And since it's a nice neat point, you could use a pattern of 1, 2, 3, 5, 7. You would get this right here. Now, we're not overly concerned about the shading part because we're just trying to solve this right here. Now, we want to know, when is your parabola greater than 0? In other words, when is your parabola above the x-axis? Because this is where the y values are positive, meaning greater than 0. Well, your parabola is above the y-axis, or positive, when you are to the left of 1, because this is where you're above over here to the left of 1. And it's also above your x-axis, where your y values are positive, when you're to the right of 3 over here, because these values are above the axis, so greater than 3. So you could say to the left of 1 is y is less than 1. To the right of 3, y is greater than 3. So that's your answer. 2, when is your quadratic greater than 0? So let's take a look at doing this one here. We can do the same thing. Since 0's on one side, we can replace it with a y and graph our resulting parabola that we get. You could make yourself a t-chart if you wanted. You get your negative b over 2a. It's a fraction, so you can't use a pattern of 1, 3, 5, 7. So you have to make a t-chart and plot your points. Plotting these points, we get a parabola that looks like this. Now, we're wondering, when is your parabola here less than, meaning below 0? So when is your parabola below the x-axis? Well, it's only below in this small part right here, in between your -3 and your 2. So it's only below between -3 and -2. Well, we would write -3 to -2 as an inequality, meaning -3 is less than x is less than -2. Well, we now want to take a look at solving quadratic inequalities algebraically. So let's go ahead and take a look at this first one. To solve them algebraically, we're pretty much going to just solve the equivalent equation. So we're going to solve the equivalent equation. So we're going to replace this with an equals and solve it by factoring. So we're going to take the 2 over, because remember, to factor it, you got to have it set equal to 0. Factor it. Then we're going to go ahead and get the 2 critical points that are going to divide our number line into 3 different regions. So you set each factor equal to 0. Solve the first one. Get 1, and then we get -2. Now, 1 and -2 divide our number line into 3 regions. 1 or 2 of these regions will end up working. So all we want to do is just try a number into that factored form. So let's try a number over here, say -3. -3 plus 1 or 2 is a negative. -3 minus 1 is a negative. Is a negative times a negative going to be less than or equal to 0? A negative times a negative is positive, not less than 0. So it does not work over here, so we're not going to shade over there. We try a number in between, say 0. 0 plus 2 is positive. 0 minus 1 is negative. Is a positive times a negative, which is a negative, going to be less than 0? Yes, because negatives are less than 0. So we tried a number in between. It worked. We're going to shade there. Then we try a number over here. Say 5. 5 plus 2 is positive. 5 minus 1 is positive. Will a positive times a positive, which is a positive, be less than 0? In this case, no. So your answer is between here. We're including these because we had an equal to, less than or equal to. So we get -2 is less than or equal to x is less than or equal to 1. So now we're going to do pretty much the same thing for this one over here on the right. Replace your inequality with an equals, set it equal to 0, and factor it. Set each factor equal to 0. So we get -3, we get -2. So now we're going to take our -3 and our -2 and put them on a number line and check the regions that it separates it up into. So we go ahead and try a number in each region. So let's try a number over here, say -4. -4 plus 3 is negative. -4 plus 2 is negative. Well, a negative times a negative be greater than 0. Well, a negative times a negative is positive. That is greater than 0, so yes, that does work. So we're going to shade over here. Then we're going to go ahead and try a number in between, say -2.5. -2.5 plus 3 is positive, but -2.5 minus 2 is, or plus 2 is negative. A negative times your positive here is a negative answer, and that's not greater than 0. So it does not work in between, so we cannot shade. Over here on the right, we try an answer, say, or a number over here in this region, say 0. 0 plus 3 is positive, 0 plus 2 is positive. A positive times a positive is greater than 0, so we're going to shade there. Two separate regions up here graphed, so you're going to have two separate inequalities. And there we're done.